Alright guys, let's look at some basic probability. Now first of all, we're going to be having a look at the range of probability by looking at a scale. Now I've got a little scale over here. I'm going to start from my left. I'm going to call that be 0. If the probability is 0, guys, it means it's nothing. This means it's impossible. It's not likely at all. So it's impossible. That's what a probability of 0 indicates. Now let's look all the way to our right hand side. It's the other side of the scale. In this case, it's 1. I'm going to call it 1. 1 is same as 100 over 100, which is 100% basically. So if it's 100% probability, which means it's 1 probability, that means it's certain, it's definite. Okay, so it's certain. That's what a 1 is. So you can call the total probability be 1, being 100%. Alright guys? Now let's look midway. In the middle, guys, it's pretty much 0.5, half, isn't it? If it's half, we call it even chance, 50-50 chance. Alright guys? Now, if we look further towards 0, if the probability is closer towards 0, we call it not likely, unlikely, very, very low chance of happening. And if it's closer towards the total probability of 1, it's almost certain, most likely, okay? Almost certainly. That's something you might want to know. So those terms, please keep an eye on those and know what they mean, because they will be frequently coming out in probability questions. So you need to be very, very familiar with them. So let's go on to the questions now, guys. I'm going to go to question 1. And each question, guys, has a background context. And in this one, it's about tossing a coin. Now, firstly, for A, it says write down the sample space. Now, the sample space means list down all the possible outcomes in this particular scenario. So if it's tossing a coin, what kind of outcomes do we have? It's head or tail. It's either a head or a tail. You just got to remember this. There's 2 different types of outcomes we can have. So that is just all the sample space we have. Now B, is the outcome equally likely? Yes, it is. We could equally get a head and a tail. So it's equally likely. The probabilities are the same. And part C says find the probability that a head is shown. Now, head is just one out of the 2 different events. So head is 1, and there's 2 different events, head and tail, so it's 1 out of 2, which is a half chance. Now similarly, same for tail. Tail is also a 50-50 chance. It's half. Alright, because it's 1 out of the 2 events. Make sense, guys? So that's question 1. Let's go to question 2 now. It says the context is about the gender of a baby. So I've got our little baby here. Now first of all, I want to write down a sample space. Now as I said, guys, sample space is all the different types of outcomes we can have. Now, the gender of a baby could be a girl or a boy. That's it. That's the sample space. Now B is asking us, is each outcome equally likely? Well, yes it is. It's equally likely of getting a boy and a girl, isn't it? Not one is more likely than the other. We can't really guarantee that. We can't really say that. So it's yes, it's equally likely of getting a girl and a boy. Now C, find the probability that the baby is a girl. Now if it's a girl is just 1 out of the 2 different events that we have. Girl is just 1 event out of the 2 different events of girl and boy. So it's 1 out of 2, which means a half chance. And that means that's the same for the boy. Boy has an also chance, a probability of half as well. Alright, 50-50. Now guys, look at 3. What we want to discuss is the first letter of a person's name. Now the first letter of a person's name, maybe Andrew is A, Ben is B, Catherine is C. So you just got to know all the different types of alphabets we can use. So part A is asking us to write the sample space. What is it going to be, guys? A, B, C, D, all the way through to Z, the alphabet, the letters in the alphabet. It keeps going. It's going to be a long list because I'm sure that in this world there's going to be all of these alphabets are going to be used for any person's name. So we use all the alphabets. Alright guys, so A through to Z. So you just list them out. It's going to take a bit of time. But anyway, we'll go to B. Is it equally likely of getting these outcomes? Now, I know a lot of you will say yes, but unfortunately it's not. It's no, the answer is no. Because if you think a bit more realistically, guys, some alphabets are a bit more popular than others. We can't say that there's the same amount of people who has the letter Z in their first name and the same amount of people who have letter B in their first name. It can't be equal. It's very, very fluctuated, isn't it? So we can't say they're equal. There's some letters of the names are a bit more popular than others, so that's why it's a no. Alright guys? Now, Let's move on to question 4. Tossing a 6-sided die. So part A, we want to first of all write down the sample space. Now you've probably seen a die like that at school or at home when you're playing games or Monopoly or something like that. There's 6 equal-sided faces and they're labelled 1 through to 6, isn't it? So the sample space, as I've just said, it's 1 through to 6, all the numbers. Now B, is each outcome equally likely? Well, as I said, all the sides of a dice are evenly spaced, they're all the same shape, okay? Unless it's like a bent die or something crazy, it's definitely equally likely. They're all same sided and their shape is the same, their size is also the same, so it's equally likely. Now C, find the probability that it shows a 4. So if it's showing a 4, 4 is just one outcome out of the total of 6 outcomes, so it must be 1 out of the 6. Alright guys, that's all. So probability of getting a 2 would also be 1 out of 6 because 2 is only 1 out of the 6 numbers. Same for 3, same for 5, same for all the other numbers on the die. So you might want to remember that. Now D, find the probability that it shows an odd number. Now guys, tell me, out of the sample space that we've listed, how many are odd? Or hopefully you guys know that 1, 3, and 5 are odd. So 3 of them out of the 6 are odd. So 3 out of 6, and make sure you simplify it, which is 1 over 2, a half. Alright, so half of them are odd, which makes half of the other half be even, isn't it? So make sure you're trying to remember that, and always simplify your probabilities if you can. Alright guys, question 5, spinning a spinner. So I've got my spinner here. We're going to specifically look at this spinner. So part A is asking us to write down the sample space. Now, there's 2 sets of sample spaces here. If you talk about numbers, it's 1 through to 8. See how there's numbers 1 through to 8? And if you're talking about colour, it could be yellow or blue. So we can split the sample space into numbers and colours. Alright guys, and you list it all out, but you're going to list all of them out when they ask you for the sample space. Now B, is each outcome equally likely? Well, in number-wise, 1 through to 8, they're all equal pizza slices, so yes. And same with colours. See, 1, 2, 3, 4 of them are blue, and 1, 2, 3, 4 of them are yellow. So yes, they're equally likely. So part C, if we want to find the probability that it lands on a 3, see, 3 is just 1 out of the 8 possible numbers. So it must be 1 out of 8. That is it. Now, D, find the probability that it lands on blue. Now, so to find the probability, guys, we have to find the number of blue pictures, or whatever you call it, blue spinning parts, over the total colours that we have. Now, blue is 1, 2, 3, 4. And if we want to incorporate blue and yellow, which is the total parts, there's 4 blues, 4 yellows, altogether there's 8 lots. So blue is only 4 of them, so it's 4 out of the 8, which is simplified to 1 over 2, which is half. Alright guys, so it's half chance of getting a blue. Alright, let's move on to question 6. Okay, it says spinning a spinner, so it's another spinner, but it's a different one. Have a look guys, we've got a different one, it's more involving colours. So if I'm asked to write a sample space, it's pretty much just blue, red, yellow and green, just all the colours there are. There's no numbers in this one, so it's just colours. Now, is each outcome equally likely? Well, what do you think, guys? Do you think it's equally likely or not? I think it's no, because yellow, there's only one part, whereas red, there's more parts. They're not all equally likely. They all have different numbers of parts to it, don't they? So it's definitely not likely. Now, part C, it says find the probability that it lands on red. Now, to find the probability, there's 5 reds out of the total of 12 parts, isn't it? See, if you count up all the different sections, there's 12 of them, and red, you can see that it's 1, 2, 3, 4, 5. So there's 5 reds out of the total parts of 12, and that's it, okay? Now D, it's asking us to find the probability that it lands in pink. Now guys, is there any pink, guys? In the sample space, we didn't have any pink. There was no pink. So in this case, it's just 0. There's no pink. There's no way we can have pink, so it's unlikely. So it's impossible. Fully unlikely, so it's impossible, which makes 0. Alright guys? Okay, question 7. Alright, let's have a look at this. There's some coins. We're going to look at choosing a coin. And it's specifically going to be looking at these coins. So, I've got some Australian coins over here. Now guys, first of all, what we want to know is each outcome equally likely? Well, what do you think? What do you think, guys? I think no, because every coin has different numbers of numbers. So I don't know. There's what, two $2 coins, one $1 coin, one 50 cents, two 20 cents. There's all different numbers of numbers. If we have equal numbers of each coin, then it would be yes, but unfortunately this one, no. They're not equally likely. Now B, we want to find the probability of a 50-cent coin. That's what this little notation means. Make sure you get familiar with that. Probability of a 50-cent coin. Now 50 cent is just 1. So it's just 1 out of the total. If you count up the coins, there'll be 8. So it's 1 out of the 8. Alright guys, that's the probability of getting a 50-cent coin, only 1. Now C, find the probability of not a $2. So what I'm going to do is count how many non-$2 there are. So that one's not a $2, yes, not a $2. I'm going to circle all of them that are not $2, and that's the final one. The 10 cent is definitely not $2. So it's everything but those two that are not $2. If you count them up, there's 6 of them, isn't there? And 6 out of the total of 8 will be the probability. Now guys, don't stop there, please simplify it. I know that 2 is divisible by, 6 and 8 are both divisible by 2, so I've simplified it to 3 on 4. Alright guys, make sure you simplify your probabilities. Now D, we want the probability of a gold coin. How many gold coins are there? Please count them for me. We've got 1, 2, and 3. So 3 gold coins out of 8. So 3 out of 8 is the probability of getting a gold coin.